Can I go?
Okay, so here's what you've got. So we're going to have a block of wood with a mass of, make it simple,
1 kilo
1 kilogram. We're going to have a bullet
of
flying towards the block,
0.02 kilos.
and it has a mass of 12 grams. Okay? So when the bullet hits the block, there's three things that can happen. The bullet can pass through the block, okay? The bullet can hit the block and bounce back, okay, like a rubber bullet. Or the bullet can become embedded in the block, and they move off together like the California problem, okay? So, no matter what, they all start the same way. Where you go, okay, the momentum of the bullet plus the momentum of the block equals the new momentum of the bullet plus the new momentum of the block, okay? If it was a squirrel and a rubber band, you'd say the momentum of the squirrel plus the momentum of the rubber band, okay? Whatever it is, they all start the same way. Now, in this situation, not all of them, one of these momentums might be equal to 0. So the block of wood is at rest, okay? So it doesn't have any momentum. So I don't have to worry about that because the block is at rest. It has mass, it has inertia, it's just not moving, okay? So it doesn't have any momentum. So on this first one, we're going to assume that the bullet is going to become embedded in the block, and they're going to move off together. So that would be like me sitting here, and Dylan throws Hank at me, I catch Hank, and we move off together like this.
Are we gonna do that one?
Wouldn't that hurt a lot?
It would hurt a lot.
Yeah.
So the point being is they're going to hit, and they're going to move off together. It's going to be a California problem. So I know that afterwards, I measure how fast they're moving after the collision. And let's say that's moving at 1.80 meters per second. So what I want to know is what's the initial velocity of the bullet. And this is how they determine velocities of bullets. It isn't like I can sit there and go, start, stop, fire the gun, and measure how long it takes for a bullet to travel because it's such high speeds. So what they do is they shoot it into a block of wood. They measure how fast the bullet and the block of wood is moving afterwards. And then they work backwards to figure out how fast the bullet was moving before it hit the block of wood. Okay? Because 1.8 meters per second, that's pretty easy to measure. Oh, you set it up, you let it travel 1 meter, you measure how long it takes to travel, boom, there's your velocity. Vanessa?
Nothing.
Yeah. So, this is going to be at 0. It doesn't have to be at 0. It just happens to be 0. If the bullet was moving away or moving towards, this would not be a 0 value. Okay, but the block just happens to be at rest. So, here's the next step. Okay, this is going to be the mass of the bullet times the velocity of the bullet. This is going to be the mass of the bullet times the new velocity of the bullet plus the mass of the block times the new velocity of the block. Okay? Now, what do you know about the new velocity of the bullet and the new velocity of the block?
They're the same.
They're the same because they've hit and they've moved off together. Okay? So these two velocities are the same. So what can I do?
Multiply them together.
Well, factor it out, right? I can factor out that new velocity. So this is going to be the mass of the bullet times the velocity of the bullet equals the mass of the bullet plus the mass of the block times some v prime. Now, listen to me. This is a great step, but you can only do it if it's a California problem and they move off together, okay? If it hits and bounces, or if it hits and passes through it, you can't do that. You have to treat these as separate entities. But if, this is huge if it's a California problem, they're going to hit and they're going to move off together. Okay. So, I got a mass of 12 grams. Gavin,
What's up?
what do I have to do with the 12 grams?
You have to convert it.
Into
kg.
Kilo.
12 grams, what are you gonna do to get the kilograms?
Probably divide by 1,000 or something
And you're
like
gonna
that.
get
0.012.
kilograms, right?
Si, senor.
Okay. So, out of this, I know how fast they move off together. I know these two masses, I know the mass of the bullet. What's the only thing I don't know?
The initial velocity.
That initial velocity of the bullet. So I'm gonna divide both sides by the mass of the bullet. Okay? That goes away. Cool with that? Got it. So let's talk about this initial velocity of the bullet. Is the initial velocity of the bullet, before you do any math at all, is it gonna be bigger or smaller than 1.8 meters per second?
Bigger.
Bigger. This has less mass, but, and don't underestimate the importance of this equality sign here. Whatever those momentums are, have to be the same on both sides. Since this has such more mass because it's a 1 kilogram block plus the bullet embedded in it, that mass here is really, really big. So to balance that out, that bullet, to have the same momentum, has to be going really fast, okay? Now, would it be possible in this situation, when I find the initial velocity of the bullet, for that to be a negative value
It's possible.
in this situation?
The velocity.
Oh, wait,
No.
never mind.
No.
No.
Could never, in this situation, it can never be a negative value. Why?
Because we've defined the right.
We're both
That's
moving
possible.
right.
Yeah, it's moving to the right, and all these numbers are positive.
Yeah.
Okay? Now, I don't want you to sit there and go, oh, it can never be negative. Oh, it could be, it just can't in this situation. So, now we can finally do the math. So we have the mass of the bullet, 0.012 kilograms, plus 1 kilogram, times 1.80 meters per second, because that's how fast it was moving after the collision. And then I'm going to divide that by 0.012 kilograms. Now, could I just cancel out this 0.012? Dylan,
No.
No.
absolutely not. Why?
Because
Yeah,
there's
it's a
addition right
multiplier.
next to it.
Yeah, you're adding them up here, you're not multiplying them.
Yeah.
Okay, so somebody take a calculator.
152.
What'd you get?
152.
152?
I got 152.
So the initial velocity of the bullet
I believe it.
is 152 meters per second.
I should do it.
That's a
Okay.
lot.
Now,
1, 2.
that seems reasonable because of the fact that
It's a bullet.
it's a bullet. The speed of sound is about 330 meters per second, so this thing is like half the speed of sound.
What kind of bullet are we talking?
It doesn't matter, not
I mean,
the point of the story.
It,
A
Not-
bullet,
shh,
Dylan.
Not the point of the story,
it,
not the point of the story.
like,
Okay.
like a 22
Now,
versus a 9mm, like. is
Could I, at this point, if I wanted to, and I do, could I calculate the change in momentum of the bullet?
Yes.
Yeah.
What would I need?
No. So you have
The original minus the final
What, mass, velocity, force,
velocity.
what?
Velocity.
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 So, at this point, to get the change in momentum of the bullet, that's gonna be mass times V minus V naught. Simple thing. So in this situation, I've got 0.012 kilograms times my final velocity, which we said was what, 152?
Yeah, 152.
Minus, no, I'm sorry. My final velocity is 1.80. I screwed that up. Okay, this is, we're gonna violate the laws of physics. My final velocity was 1.80 meters per second, and my initial velocity was, what we get, 153?
152.
152.
Is it 150? That's gonna be a big difference, 152 or 153?
152.
151.
It's at the bottom.
151.8.
So 152. Okay,
Looks like 132.
so somebody take .012 times 1.8 minus 152 and give me a number.
Negative 151.9784.
Whatever Dylan said.
So negative what?
151.9784.
So negative 152?
I got negative one.
That doesn't seem right.
No, that's not right.
I got negative 1.8.
1.80.
That sounds a lot better.
So Dylan, how are we messing up calculations that are on the board?
Divided it.
Parentheses.
Be
Or just
nice.
things where you do
Frick no.
Negative 1.80?
Yeah, Dylan.
I just did it without the.
Yeah, negative 1.80.
Usually.
Yeah.
Yeah, negative 1 point.
Because
I don't know
otherwise,
what this
we
guy's
just
doing.
violate every law of physics that
That'll
exists.
be.
Actually,
No,
no.
Bird, don't erase.
All I'm erasing is these top numbers.
Yeah, I
Okay.
got negative
okay.
1.8024.
Okay.
Yeah.
Now,
I like them so much. Yeah. Very.
since the block the bullet took off at 1.80 meters per second, could I find the change in momentum of the block?
C.
Yeah.
Yeah, so the change in momentum of the block is gonna be 1 kilogram times its final velocity, which is, oh, look at this.
1.8.
Oh, it equals
No
out.
way.
Oh,
It's almost like.
Oh, it's like the
Yeah, I-
conservation
coincidence?
I think
I
so.
think so, yeah.
conservation of momentum.
Momentum has to be conserved. So whatever momentum was lost by the bullet has to be
In the black.
the block. Okay? Now,
Oh, you can't destroy momentum or create momentum. You gotta like. It's
Now,
like the conservation of.
let's
mass.
look at this from a velocity time graph standpoint. So the block, right?
Mhm.
The block started at rest and it ended up at 1.8 meters per second. True?
Yeah.
Indeed.
So the block's gonna go from 0 up to 1.8, and then they're gonna move off together. So here's the velocity time graph.
Something like
Right.
that.
The bullet started at 152.
Yep.
So it started way up here, and it's gonna drop down, but it's also gonna end up at 1.8.
Yeah.
Cool with that?
Yep.
Now, do I have enough information to calculate the force that was exerted on the block?
Yeah.
Yeah. No.
No.
All I know is the change in momentum. Okay, I can't calculate the force. But if I know that this time is 0.10 seconds, okay, so let's say that it took 1/10 of a second for the bullet to slow down and the block to speed up. And these times have to be the same, okay? Because of Newton's third law, this is for every action there is a reaction. So when the bullet is exerting a force on the block has to be exerting a force in the opposite direction for the same amount of time, okay? I can't walk up to Louise and punch Louise in the arm for 1 second, and Louise only punches back on me for a half a second. It was like, oh, Burkamp, I'm gonna take it easy on you, old man. I'm only gonna push back on you for a half a second, okay? No, the times have to be the same. So, if I go the change in momentum of the bullet, and I do,
I bet I could.
I'm gonna calculate,
Just have to like aim for like the face. Just snap your nose.
Remember.
the force.
God,
that finger is nasty.
Fortnite.
Bless you.
Okay, so force times time equals
Know
change
what
in
it
momentum.
stands for.
I know the time is 0.10 seconds. I know the change in momentum, the only thing I don't know is force. So, the force exerted on the bullet is gonna be negative 1.80 Newton seconds divided by 0.10 seconds. The seconds cancel out. I get units of newtons. I get
Did I say that?
negative 18 newtons, okay? Yes,
Did we gain an hour or lose an hour on Sunday?
We gained.
we lost.
So I got
It's always fall back, spring forward.
so I got an extra hour of sleep.
Good
or I
job.
lost
Yes,
an
you
hour?
got an extra hour.
Yeah, that's what I
Actually?
said.
Wait, they actually?
Yeah.
Yes, you got an extra hour of sleep.
Yeah, no, my mom told me that.
Okay, now, so does it make sense that the force exerted on the bullet is a negative value?
Yes.
Yeah.
Because it moved in with a positive velocity going in this direction, but what did it do?
Slow down.
It slowed down. So the force had to be going the opposite direction, okay? Now, that's the force on the bullet. So, what's going to be the force on the block? Well, the force on the block was
Positive.
1.80 Newton seconds, because that was that change in momentum. We divide that by 0.10 seconds. We get 18 newtons. Otherwise known as Newton's
Third one.
third law.
A third law.
Trace.
Newton's third law. So you prove Newton's third law
I think.
Does
by the
trade-
law of conservation of momentum. Okay?
Oh, come on.
Now, do I have enough information to calculate the acceleration of the bullet?
Yeah.
Do you know the force exerted on the bullet?
Yeah.
You know its mass.
So,
I
yeah.
guess.
We can find the acceleration.
Shucks.
So, somebody take negative 18 newtons and divide that by 0.012 kilograms.
Negative 666 point.
No.
What?
No.
Negative 1500.
Oh, that's-
Negative 1500.
I got point. I got.
Dude, the
Those
numbers
are
are right in front of your guys' faces.
It's
Negative
negative 18
1500.
divided by 0.012.
Yeah.
Yeah, negative 1500.
Negative 1500?
I accidentally divided it by 8.
Oh.
Not 18.
Oh, that was not our
Now,
We
assignment.
didn't even divide it by 18. Luis.
How does this fit with that velocity time graph?
But,
So,
18.
I don't know.
What? Like,
How does this acceleration fit with that velocity
that's
time
the-
graph?
That's the slope.
That's the slope.
Hmm.
So the slope here is negative 1500 meters per second squared. Now, if I take 18 newtons, which is the force exerted on the block, divide
is
that
that
by
the-
1, I just get 18 meters per second squared. So notice that the accelerations are vastly different. So, here's the absolute golden rule. Every time you have a collision, there are two things that are always equal and opposite. There's no exceptions to this rule. Zero. These are laws. Okay? These are laws. These aren't suggestions, maybe just on test days. Okay? Yeah, whatever. No, these are invariant. Anytime you have a collision, the forces are always equal and opposite. It's Newton's third law. The changes in momentum, always equal and opposite. The only thing that's not equal and opposite are the accelerations, because the accelerations are dependent upon mass. Okay? So, promise you, there's no exceptions to this rule. So if I tell you a bullet hits a block of wood, what do you know about the forces? Don't overthink it. Forces have to be the same but in opposite directions.
Yeah.
What do you know about the changes in momentum? Same values
Opposite.
have to be in opposite directions. Okay? Cool with that. Now, if you look at changing momentum, so what do you think is going to require more force? For me to catch this ball, or for the ball to bounce off the floor?
same.
Bounce.
Why bounce?
Or wait,
I
yeah.
don't know. I just remember you saying it back there when something
Yeah.
bounces.
Bounce
Cause-
Oh.
Because it has to
Because
stop
if I
and then
just
go back
catch
up.
it, what does the velocity go to?
Zero.
Zero.
'Cause,
But if it bounces, the velocity has to go from a positive number to
Zero to
to a negative number. Now, you can actually feel this. So, Gavin, I'm gonna throw this to you. I just want you to catch it
Okay.
first time. Just one hand, just catch it, okay? Right? Got that. Now throw it back. Now, next time, I want you to use your hand as like a tennis racket
Hit it.
and hit it back to me.
Okay, I'll
Okay,
see how
ready?
accurate I can be with this. Yep.
Oh no! What did I hit?
You took down the reindeer, man.
Oh no!
Reindeer down.
Did it break?
No, that's good.
Oh, okay. As long
So,
as it didn't
Gavin,
break.
what felt like it took more force? Stopping the golf ball or hitting the golf ball
Probably
back?
hitting it.
Absolutely.
Yeah.
Okay? You can feel this. Okay? So anytime something bounces,
You gotta say
that
reindeer.
requires more force. Okay. Stop that camera for the last time.
Oh my god.
Hold